I'm asking you to do here is find the equation of the tangent line to f of x equals tangent x at x equals pi over 4. You should be able to do this problem without a calculator and all its values. So you'd start this by writing down the equation of the tangent line, or any line, that is. Okay? So that's the equation of any line. You need two things. You need to know what the slope is, and you need to know what the y value is. You already know the x value. Here it is, right there. So you can do x minus pi over 4 right away. Okay? Now, to get the y value, you just have to take your value of x, which is pi over 4, and sub it into the function. So f of pi over 4 is equal to the tangent of pi over 4. The tangent of pi over 4 is just 1. Okay, so that's not bad. So you have y minus 1 equals blank x minus pi over 4. Oop, hold on a second. It should be a 4 down there. Okay, now to get the slope of this thing, you need to find the derivative of your function. So if your function is equal to tangent x, then you need f prime of x. Well, the derivative of tangent x is secant squared x. We showed that in a different lesson. All right, and we just got to plug pi over 4 into that. So this will take a little bit of work, but it's not too bad. So f prime of pi over 4 is secant squared of pi over 4. Okay. That really means 1 over the cosine squared of pi over 4. All right. So the cosine of pi over 4 is rad 2 over 2. So this becomes 1 over the square root of 2 over 2, whole thing squared. And you just keep plugging along here. The square root of 2 squared is 2. The square root of 2 squared by itself is just 4. So you have 1 over 2 over 4, or 1 over 1/2. But 1/2 goes into 1 twice. So there's your slope. And then that's it. This thing here is the equation of your tangent line. So just a quick reminder of what this thing looks like from a picture point of view, like a graphical point of view. The graph of y equals tangent x looks like this. Sort of famous. You spend a lot of time studying this. This is x equals pi over 2. This graph has a bunch of vertical asymptotes, a bunch of VAs. Here's x equals negative pi over 2, and so forth. All right. Pi over 4 is halfway between 0 and pi over 2, so it's right there. And we go up to the graph, and there's a tangent line there. There's the point of tangency, and then here's the line that goes by. So what we just did is we found the equation of that line. And it looks like that. So just a reminder of what we're doing geometrically. Okay? All right, so can't quite leave this topic yet. What do we know so far? We've shown that if y equals the sine of x, then y prime is the cosine of x. We've shown if y equals the cosine of x, then y prime is sine of x. We've showed that you can have fun. You can think like this, for example. You can say, hey, what's the fourth derivative of maybe that function? If we're starting at y equals cosine x, what's the fourth derivative? And we showed this nice pattern that arises. So for example, to do that problem, if you had y equals the cosine of x and we want the fourth derivative, y prime would be negative sine of x. Y double prime, well, if we know the derivative of sine x is cosine of x, then the derivative of negative sine x would be negative cosine of x. Okay? Then y triple prime, well, normally we know the derivative of cosine of x, I left something off here, sorry, is negative sine x. That means the derivative of negative cosine x would be positive sine x. And then lastly, the fourth derivative is just derivative of sine x, but now you're back at cosine x. So we've noticed this pattern that when you take the derivative of sine or cosine, every fourth derivative is the same as the original. So that's sort of nice. You could say things like, hey, what's the 200th derivative? Let's pretend for a minute that y 200 means the 200th derivative. Well, that would be the same as the fourth derivative, right? Because we know that 4 goes into 200, so this answer would be cosine x, right? And then if you were to ask things like this, what about y equals the 201st derivative? Well, it's just the derivative of the 200th derivative, and that's going to be negative sine x. But you'll notice that that's the same thing as the first derivative. And that's because if you take 200 and divide it by 4, you get a remainder of 1. Okay? So that's sort of fun stuff. What else did we learn? We showed that if y equals the tangent of x, then y prime is secant squared x. So what's left? Well, a few more functions. We forgot about cotangent x. What's y prime? So that might be worthwhile one to try. Let's do that. So my hint is, think of cotangent as cosine of x over sine of x. And that's not y prime, actually, so let's be careful. That's just y. I'm rewriting the original. And now when you go to find y prime, you can see that you have a quotient of functions. So use the new quotient rule you learned, which was low d high minus high d low over low squared. So what does quotient rule tell us? Well, it's the low function, or the bottom function, times the derivative of the top function, with the derivative of cosine would be negative sine x, minus the bottom function, or I'm sorry, that's not true, the top function. It's low d high minus high d low. So cosine x, d low, the derivative of sine is cosine of x over the low function, or the bottom function, squared. Okay, so let's take a look at that top. And if we notice, we multiply these things, that's going to give us negative sine squared x. Over here, you're going to have minus cosine squared x over sine squared x. All right. But now I look at that numerator, I'm like, wait a minute. I wish that said sine squared plus cosine squared. It'd be so nice if it said that, but it doesn't because these negatives are here. So if we do that, factor out negative 1, we end up with sine squared x plus cosine squared x. But that's what I really wanted. And happy to say that this thing here is just 1. Well, that's pretty nice. And then you end up with negative 1 over the sine squared of x. Or we can write that as negative cosecant squared x. So now you have another derivative. So you know if y equals the tangent of x, cotangent of x, then this over here is y prime. So that's pretty nice. Still 2 more left to go, right? Let's think about those. Let's not forget y equals cosecant x, and then also y equals the secant of x. Got to try these 2 problems. Give you a piece of advice. Think about what cosecant equals. It's really 1 over the sine of x, and then proceed using quotient rule. On the bottom, this is 1 over cosine of x. And again, proceed using quotient rule. So we go. So it's low, bottom function, d high, the derivative of 1 is 0. Oh, that's pleasant. Minus the high function, 1. D low, the derivative of sine is cosine of x. And then on the bottom, it's the bottom squared, so sine squared x. Okay. So the only thing left on top, really, is negative cosine of x. And on bottom, you have sine squared x. Now I'm going to write this, choose to write it this way. And this is just convenient. I'm going to write this as sine x. And I can do that because that's what it means to square something. I multiply it by itself. Okay? And then if we carefully inspect this, what you'll notice is you have 2 signs on the bottom. So I'm going to treat this as 1 fraction and this underneath 1 as another fraction. So I'm just doing this to get the answer that you see in most textbooks. So this is negative cosine x over sine x times 1 over sine x. So you could finish by realizing, hey, wait a minute, that has another name. That's negative cotangent x. And then this thing here is cosecant x. And that's the answer you'd see in most textbooks if you looked up the derivative of y equals cosecant x. You'd see negative cosecant x, cotangent x, or maybe the other order. So let's give this a shot. Ready? So it's going to be low d high. So cosine of x times the derivative of the top would be 0. Oh, that's sort of nice. Minus the high function, 1 d low. And the derivative of cosine is negative sine. So be careful with those SIGNs, those signs, right? Don't lose those negatives. Over the bottom squared, or low squared. Okay. So on top now, what you end up getting is positive sine x, because these 2 negatives become a positive. And then on the bottom, I'm going to do the same trick I did before. I'm going to write this as cosine x, cosine x. All right, there you go. So I'm going to do this next. I'm going to make this as sine x over cosine of x times 1 over cosine of x. And I can do that because if I think about the product of these two fractions, it would give me that fraction. So I know it's okay to write it this way. But now that it's written this way, I can clearly see this first part, well, that's just tangent of x. And the second part is just secant of x. And that's y prime. So that is the way you usually see the derivative of secant x written in most calculus textbooks. Here we go. So let's try a problem like we started off today. So find the equation of the tangent line to f of x equals secant x at x equals pi over 3. And this would be a problem you should be able to do without a calculator. This would be a no calculator problem. Let's give this a shot. So what do we know? Equations of lines generally look like this. Y minus y1 equals m times x minus x1. You already know x1. That can get plugged in right away. X minus pi over 3. And to get y1, it's not so bad. You just got to do f of pi over 3. Take the x value and sub it into the function. So in this case, it means find the secant of pi over 3. Or some of you might think of that more fondly as the secant of 60 degrees. Okay, so this is 1 over the cosine of 60 degrees. And the cosine of 60 degrees is 1/2. So you get 1 over 1/2, which is 2. All right, so surprisingly nice. So that's going to be 2 there. And then the last piece is to get the slope that's missing. But slopes come from derivatives. So we need to do f prime of x first. And we just showed that if f is secant x, then the derivative is secant x times tangent x, or other order, doesn't matter. Okay? So we need to find f prime of pi over 3, which is the secant of pi over 3 times the tangent of pi over 3. All right. So what do we know? Well, the tangent of pi over 3, the tangent of 60 degrees is square root of 3. That's one of the values that you should just know. For secant, we'll think of that as 1 over the cosine of 60 degrees. But that's 1 over 1/2, or 2. So that whole thing's 2. So when we're done, we end up getting 2 times the square root of 3 as our slope. So we can sub that into our tangent line, 2 times the square root of 3. And that thing there is the equation of your tangent line.